80%. I mean, if you manage an analytics team, or even if you're a business intelligence developer yourself, that single number should probably keep you up at night.
Oh, absolutely. It's a terrifying stat.
Right, because according to the industry data we're looking at today, 80% of an analytics team's time is spent on just like preparation, structuring, and maintenance work, which leaves a tiny 20% for actual analysis.
Yeah, which is completely backwards. Yeah.
Exactly. So welcome to Data Design with Mokkup. I am super thrilled to announce we are bringing you episode 18 today. And our deep dive is tackling exactly how that massive imbalance happens.
And more importantly, how it's actually being fixed.
Yes, exactly. We are exploring Mokkup.ai's new Tableau semantic export and, well, just the general evolution of dashboard wireframing. So the mission for today's deep dive is to figure out how this agonizing disconnect between dashboard design and development is finally being bridged, saving teams from endless rework.
It really is a systemic bottleneck across the entire data industry. What we are analyzing today comes straight from Mockup's latest release documentation, and it highlights a really major shift.
Yeah.
Because for years, the friction hasn't really been in the ideation phase, right? Stakeholders generally know what they want to see. The friction is entirely in the execution.
The handoff.
Exactly. Specifically, that handoff between the person designing the dashboard and the person actually building it.
Because the traditional workflow, it always sounds great on paper. You map out your layouts, you figure out your key performance indicators, you get the wireframe looking incredibly sharp.
Everyone signs off on it.
Right. Stakeholders sign off, they love it. But then you hand that wireframe over to the developers and the momentum just totally stalls out.
Yeah.
Because under the old paradigm, that wireframe was essentially just a static picture.
Yeah, it was just a visual.
Right. So the developer had to sit down and completely rebuild all the underlying formulas, the calculated fields, and the data structures from scratch inside Tableau.
And we really need to examine the mechanics of why that happens, Tableau themselves have explicitly pointed out that data prep and structuring are the absolute biggest bottlenecks in the analytics lifecycle.
Oh, for sure.
For the last several years, exporting a wireframe from Mokkup to Tableau did a highly respectable job on the visual front.
Yeah.
Like, it kept the layout intact, the chart types looked correct, and it populated everything with mock data.
So the reviewers can see a realistic representation.
Right. But that illusion vanished the second a developer opened that .twdx file to connect it to live data.
Yeah, the documentation actually calls what happens next a layer cake of manual rework.
Yeah.
Which is such an interesting way to phrase it.
It's very accurate.
It really is. It's kind of like, it's like an architect handing you this beautiful, highly detailed blueprint. But to actually build the house, the construction crew has to, personally invent the bricks and the plumbing before they can even pour the foundation.
That is a perfect analogy.
The scaffolding was there, but the utility lines were just totally missing.
Yeah, that is a highly accurate way to look at it. And the breakdown of how this manual rework manifests, like chart by chart, is really significant. It is not just a matter of copy-pasting some code.
No, it's not at all.
The source documentation notes that every single chart type handled those mock fields differently. So the developer had to approach each visualization with a totally unique fix.
Right.
Take your standard axis-based charts like line, bar, or area charts. The developer had to manually hunt down the mock dimensions and measures in the rows and column shelves and swap them out one by one.
For the live data fields, yeah. And it gets far more complicated when you step outside, just standard bar chart.
Oh, absolutely.
The text specifically calls out histograms. In Tableau, a histogram requires you to take a continuous measure and create discrete bins for the data.
Right, the data grouping.
Exactly. And the mock data had its own arbitrary bins. So when you rip out that mock data to connect your real database, the entire chart just collapses.
It breaks completely.
Yeah. The developer has to go in, recreate the bins using the real data distribution, and completely reconfigure the axis.
Precisely. And when we move into advanced visualizations, that manual configuration just multiplies. Waterfall charts are a perfect example.
Oh, those are notorious.
Right. They don't just work out of the box. They rely on specific Gantt bar configurations, running totals, and these custom offset formulas.
Yeah.
So when the developer swapped the data source, all of those custom formulas that were tied to the mock data evaporated. The visualization would literally break until the developer went in and rebuilt the logic to match the actual business data.
And the text also mentions Sankey diagrams, which, Anyone who uses Tableau knows they can be incredibly temperamental.
Oh, they're so fragile.
They really are. They require very specific path structures or like data densification. The documentation notes developers often had to completely remove and re-add fields just to get the flows to reconnect properly.
Okay, it's tedious.
And then you add in KPI cards requiring freshly validated metrics, funnel charts depending on hard-coded sizing logic.
Gauge charts needing their own calculated fields just for a single value.
Yes, every project was essentially starting from a broken foundation.
Which brings us right back to that 80% statistic we started with. This old workflow functioned, technically speaking, but it injected unnecessary manual effort into almost every single step.
Yeah, and it's expensive effort.
Exactly. When you have highly paid, experienced Tableau developers spending hours just replacing mock fields and debugging broken table calculations across 15 different visualizations, you are draining the team's efficiency.
And drastically increasing the margin for human error.
100%.
So how do we get past this? The core of our deep dive today really focuses on how Mokkup is fundamentally changing this architecture with two specific features.
The two-part solution.
Yeah, and the first piece of the puzzle is called Convo.ai. Let's look at how this changes the entry point for designing a dashboard.
So Convo.ai represents a natural language interface for wireframing. The premise is that you can just describe the dashboard you need using everyday language.
Just typing it in.
Right, but you can also upload a data file alongside that prompt. Convo.ai's natural language processing reads the headers of that file, understands the context of your request, and it automatically generates the structural layout.
Okay, so if I upload a file with sales data and type, I need a regional performance tracker with a focus on year-over-year growth. The AI isn't just dropping random charts on a page.
Not at all.
It's inferring from my column headers like, region, order date, sales amount, where a KPI card belongs versus where a time series line chart belongs.
Exactly.
And it actually aligns the wireframe to that specific data set.
Right. It completely removes the blank page syndrome from the design phase. But while Convo.ai is what generates the initial visual layout, the real technical breakthrough here is the second feature.
The semantic layer.
Yes, the Mokkup semantic layer. This is the engine that actually bridges the gap between design and development.
Now, we hear the term semantic layer thrown around a lot in data engineering, usually referring to a centralized business representation of data. How's Mokkup applying that concept to a wireframe export?
Well, in this context, the semantic layer acts as a translator. It sits between the visual wireframe you built and the strict structural requirements of Tableau.
Okay.
When you export a wireframe now, Mokkup doesn't just generate a pretty picture filled with dummy values. It actively bakes the dataset, the measures, and the mathematical formulas directly into the resulting .twbx Tableau file.
Wait, so the output isn't just like a static mockup anymore. It is a fully functioning, pre-wired analytical model.
That is the crucial distinction, yeah. It ships all the required metrics and definitions inside the export.
Wow.
So those complex elements that used to break the year-over-year growth measures, the custom waterfall logic we talked about, they are pre-configured. They are actively producing values the exact moment the developer opens the workbook based on the data set you mapped in Mokkup.
Okay, I need to pause here and play devil's advocate for a second. Because whenever we talk about uploading data into a third-party AI tool, alarms just start going off for people.
Oh, absolutely, as they should.
Right.
Right.
If I am a compliance officer at like a healthcare company or a financial institution, and a designer wants to upload our highly sensitive proprietary data into Convo.ai just to build a wireframe, I mean, that sounds like a massive security violation.
Yeah.
How does this platform handle data governance?
It is the most critical question an IT team will ask, and the documentation addresses this security architecture very clearly. The system is designed to only read the metadata of the uploaded file, not the payload.
Let's clearly define the boundary there, between metadata and payload for this specific tool.
Sure. Metadata in this scenario means Mokkup only scans the structural scaffolding.
Okay.
It reads the column headers. For example, it sees a column named account balance. It reads the data type, noting that it is a numerical field. It might read the date formatting. But it never accesses, reads, parses, or stores the underlying rows of actual data. The millions of individual account balances, the sensitive customer names, the actual transaction records, that payload is entirely ignored.
Oh, I see.
The system only maps the logic of the building. It never looks at who is inside the rooms.
That makes a lot of sense. And it leads perfectly into how this actually works in practice. Let's walk through the actual workflow, because the documentation outlines a specific four-step cadence for taking a project from conception to a live Tableau Cloud deployment.
Right.
And the very first step in this workflow involves uploading a dataset into Mokkup.
And here is a vital piece of strategic advice from the source material. You should use a sample dataset during this initial step.
Not the real thing.
Exactly. Do not try to connect your massive governed production database to the wireframing tool. You simply use a lightweight sample file that perfectly mirrors the structure of your real source. So, identical column names, identical data types.
Why use a sample at all, though? If the platform is secure and, like you said, only reads the metadata anyway, wouldn't it be faster to just plug the real production data in from the start?
It comes down to agility. In a typical enterprise environment, getting access to a governed production database requires, submitting IT tickets, configuring VPNs, waiting for security approvals.
Oh, yeah, that can take weeks.
Exactly. That completely bottlenecks the design phase. By using a lightweight sample dataset, just a simple CSV with the correct headers, your design team can move incredibly fast.
That makes sense.
They can iterate on the wireframe, map the logic, and get stakeholder approval in days instead of weeks. You completely bypass the internal data governance hurdles until you are safely inside your own secure Tableau environment.
That is a very smart approach to pipeline management, just keeping the design phase completely decoupled from the heavy infrastructure.
Exactly.
So, step one, you've uploaded your structurally identical sample data, and the AI has helped you generate the wireframe. The next step, step two, is exporting to Tableau, which the documentation describes as a one-click process. It generates that fully loaded .twbx file with the layout, the calculated fields, and your sample data set already attached as the active data source.
Yes. And that brings you to the third step, the critical transition point. You open that generated file locally in Tableau Desktop.
Okay.
If Tableau prompts you to approve any extensions, which is really common for complex visuals like those Sankeys we mentioned, you just accept them, and then you perform the data swap.
Right, swapping out the sample.
Exactly. You replace the lightweight sample data set with your actual live governed data source.
Okay, I have to push back a little on this idea of a seamless one-click swap.
Fair enough.
Because in the real world of BI development, data is rarely just a flat, single table. We deal with complex multi-table joins, snowflake schemas, intricate relationships. How does a wireframe export handle complex data modeling when you do that swap? Does the whole thing just break if the underlying model is complicated?
It's a very fair point, and it highlights the boundary of what this tool is designed to do. Mokkup acts as the semantic presentation layer.
Okay.
It is not replacing your data warehouse, and it isn't meant to build complex SQL joins. When you do the swap in Tableau, you are pointing the wireframe's pre-built presentation logic to your published, fully modeled Tableau data source. As long as the column names and data types in your complex model match the structure of the sample data you use to design the wireframe, the visual pipes will align perfectly.
Got it.
You still do your heavy data engineering in the back end, but Mokkup ensures the dashboard doesn't require a manual rebuild to understand that data.
So because the formulas and chart structures in the export were built using the exact metadata schema of your production environment, the real data just flows naturally into the pre-existing architecture.
Precisely.
The charts populate, the year-over-year logic holds, and the bins for those histograms are already defined correctly.
Exactly. Which leaves you with step 4, the final phase, verification and publishing. The developer does a visual audit. You ensure the formatting aligns with your corporate design standards, and you can actually even copy the exact hex color codes from the Mokkup interface to ensure pixel-perfect brand compliance.
Oh, that's a nice touch.
Yeah, and then once verified, you publish it directly to Tableau Cloud.
When we lay the whole process out like that, the contrast with the traditional method is stark. We are talking about fundamentally altering how analytics teams spend their time.
We really are. If we look at the macro impact of this semantic export, it is a measurable reduction in friction. Consider how development cycles usually derail, right?
Yeah.
The most common scenario is the mid-build requirement change. You are halfway through development, and a stakeholder decides they need to look at the data by geographic region instead of product tier.
Oh, that's the worst.
And then they want to add a complex new conversion metric on top of it.
Under the old system, that mid-build pivot is a nightmare. The developer has to stop what they're doing, go back into the data pane, manually construct new calculated fields, restructure the existing charts, and then validate all the math again.
But with the semantic layer integration, the workflow adapts.
How so?
The designer can just adjust the wireframe and mockup, re-export the file, and all the new logic for that conversion metric is instantly baked into the new Tableau template.
Wow.
You aren't asking a developer to reverse engineer complex mathematics from a static PDF. The math is already executing inside the export.
It also seems like a massive win for consistency. Like, if you have a team of 5 different Tableau developers, you probably have 5 slightly different ways of writing a calculated field or structuring a dashboard.
Oh, undoubtedly.
Right? By generating the foundational logic straight from the wireframe, you are standardizing the implementation across the entire department.
And that standardization directly impacts team morale.
For sure.
Developers don't want to spend their time doing repetitive configuration work. Manually swapping dimensions on 15 different charts or debugging a Gantt bar calculation for a waterfall chart over and over again.
Yeah, nobody wants to do that.
By automating the mechanical setup, you are freeing up their cognitive bandwidth to focus on actual data analysis and uncovering insights. You are finally attacking that 80% of wasted preparation time.
And according to the source material, this capability is actually going to expand. Currently, this semantic layer integration is available for Tableau, but the roadmap explicitly mentions that support for Microsoft's Power BI is under active development.
Yes, and that is going to be a major development for the Microsoft ecosystem.
Oh, yeah.
The documentation states they are working on exporting .pbx files that will have DAX equivalent calculations pre-baked into them.
DAX, or data analysis expressions, is the formula language used in Power BI.
Yeah.
And anyone who has worked with it knows it can be incredibly powerful, but also notoriously complex.
Very much so. DAX is heavily reliant on evaluation contexts. Understanding the difference between a row context and a filter context is a pretty steep learning curve.
Yeah, it really is.
When a developer builds a wireframe and needs a specific time intelligence calculation, hand-coding that DAX involves multiple functions and ensuring the data model is configured perfectly.
Right.
If Mokkup can successfully map the visual logic into pre-wired DAX calculations inside the exported.pbx file, that will save Power BI developers an immense amount of debugging time.
It is a massive engineering challenge to translate visual intent into functional DAX, so that'll be fascinating to watch unfold.
Definitely.
Well, let's synthesize what we've covered today. We're looking at a structural evolution in the dashboard delivery pipeline. We are officially moving away from the era where exporting a wireframe merely gave you a static layout filled with mock data that just fell apart the moment it touched a live database.
We are transitioning to a framework where the design tool exports a fully functioning, dynamically wired analytical template. The loop is now completely streamlined. Wireframe the logic using a structural sample. Export the semantic model. Connect it to the governed data source. Go live.
Wireframe export connect go live. It completely bridges that agonizing gap between the design approval and the technical execution. The foundational architecture is built for you, allowing the data to just flow.
And as we watch these tools mature, it leaves us with an important implication to consider. We are seeing AI and semantic modeling successfully shrink the technical distance between designing a conceptual wireframe and deploying a live, calculating dashboard.
Right.
That technical gap is rapidly approaching zero. As that happens, how will this alter the structure of data teams?
That's a great point.
In a few years, will the industry still maintain a strict division between a dashboard designer who handles the business requirements and a BI developer who writes the code? Or are we watching the technology force those two disciplines to merge into a single unified role?
That is a deeply compelling question. Because if the architect's blueprint can automatically generate the bricks and the plumbing, the role of the construction crew fundamentally changes.
Exactly.
The tools are evolving, and the human roles will have to evolve right alongside them. Well, that wraps up our analysis for today. Thank you for joining us on this deep dive into the evolving world of analytics workflows. We will be back soon to unpack more of the hidden architecture shaping how we understand data. Until then, keep questioning the process.